Hi, let me discuss about what is meant by color spacing. First, let me know about what is a computer graphics. Which means computer graphics means producing the images and animation with the help of a computer is known as a computer graphics. Then the definition for color space. It is also known as a color model. Color model is an abstract mathematical model which simply describes the range of colors as tuples of numbers, typically as 3 or 4 values or color components. Example RGB color. And then second thing is color model. Color model, there are several establishment color models used in computer graphics, but the two most color is RGB color and CMYK model, okay, for printing. And there are three types of color space: RGB color space, YUV color space, YIQ color space. First thing is RGB color space. RGB color space, the most computer graphic color space are perceptually non-linear. That is, color differences vary through the space. This makes them inefficient for coding color information. Another problem is that they can be unintuitive. By this we mean that a novice may find out too difficult to specify a desired color. For example, selecting the brown in RGB space. Some color space, some RGB color space. The red, green and blue color space is widely used throughout the computer graphics. Red, green and blue are the three primary additive colors together to form a desired color and represented by a three-dimensional Cartesian coordinate. The indicator diagonal of the cube, okay, which equal amounts of each primary component, represent various gray colors. The picture contains RGB values for 100% amplitude and 100% saturated color bars, a common video test signal. In this diagram, we make there are the 8 colors, which means that a combination of two colors may form a third color. For example, we take red and blue color, we can get somewhat like orange color. There are the 8 colors which has an different shades, like in cube. Magenta, blue, white, cyan, green, yellow, black and red colors. Next thing is why RGB color is useful. Why RGB is useful? The RGB color is the most prevalent choice for computer apps because color display use red, green and blue to create a desired color. Therefore, the choice of RGB color space simplifies the architecture and design of the system. Also, a system that is designed using the RGB color space can take an advantage of large number of existing software routines since the color space has been around a number of years. Um, in CRT, they make use of the three colors. At first we have learned about the CRT. The combination of two colors may get a third color. Only the black and white cannot be displayed in CRT tube, but by which the combination as an RGB can display in a different colors, like shadow mask like that. YUV color space. YUV color space is which as a National Television System Committee, SEEM. There are some committee which has performed an YUV color space. The black and white color system use and luma information, color information was added in such a way to that can black and white receiver would still display a normal black and white picture. Color receivers decoded the additional color information to display a color prime. The basic equation to convert between a gamma corrected RGB and YUVR. There are some correction which there's Y has different value, U has different value, V has different value. By this we can calculate the rays of YUV. And then YIQ, which is YIQ is derived from the YUV color space. I stands for in phase, Q stands for quadratic, which in the modulation method to transfer the color information. This has some equation which can calculate I as an sine cos value and sine value, Q as an cos value and sine value, and this we can calculate the YIQ color space. Next thing is HSV color model, single HSV color model. It's look like an hexagon shape in which white has an 1.0, which has an center point, green has 120 degree, yellow has 60 degree, and red has 0 degree, and cyan has 180 degree, somewhat like that. This is some systematic structure of HSV color model and the table representation. In S and V, the black can accept the values as zeros and can accept the values as zeros, and white can accept the values as zeros and ones. And rest all the same: yellow, cyan, green, magenta, red and blue can access. H is normal ranges from 0 to 360 degree. Yellow has 60 degree, cyan has 180 degree, something like that, and S has binary values zeros and ones. D has and some values as 0.75, which can accept all these things. Double hexagon HSI color model. In this we make use of some type like pyramid shape and the table representation for double hexagon. In this white to blue, it can accept the I value as 0.375 and white as 0.75, black as same zero values. Gamma correcting. Why this gamma correcting is useful means sometimes the values cannot be calculated from RGB. By using the gamma correcting, we can calculate the different colors. We can calculate the values of RGB. Now let me discuss about the transfer function of most display produces an impedance that is proportional to some power of the signal amplitude. As a result, high intensity ranges are expanded and low intensity ranges are compressed. This is an advantage in combating noise as a I approximately equal to sensitive and equal to relative intensity by the gamma correcting Wigner signals display. The intensity output of the display is rough line and transmitted induced noise is induced. This is the effect of gamma, which is a systematic representation. In non-CRT, how this picture is displayed clearly. Let me discuss about. By using the gamma correcting, we can display the picture clearly in non-CRT displays. Many non-CRTs have different gamma that used for video. To simplify interfacing, the display drive electronics are usually designed to present a standard CRT transform with a gamma of 1 by 0.45. The display drivers electronics then compensate of actual gamma on displays. And then this constant Lumia problem. Some of the UV rays cannot accept that all the values. By using the gamma correction, the UV rays values are calculated. For high color frequencies, U and V disappear, and consequently RGB degraded to equal to only Y. These are the several models that we discussed in color spacing. Thank you.